Welcome to this session on policies and regulations for solar PV deployment. Solar energy is a cornerstone of the global energy transition, providing energy access and significantly reducing carbon emissions. However, challenges such as intermittent generation, infrastructure gaps, and high initial costs hinder its large-scale adoption. Policies and regulations are pivotal in overcoming these barriers, creating a robust framework for sustainable growth and innovation in the solar PV sector. In the solar PV sector, policies and regulations are vital for overcoming deployment challenges. Long-term strategies, including budget allocations and scheme declarations, provide essential visibility and stability for stakeholders, facilitating solar technology adoption. Key provisions include identified applications and targets. Policies must define the need for solar energy, focusing on green energy adoption and cost reduction. Applications like utility-scale projects and solar pumps should have clear targets. Incentives. These can include feed-in tariffs, FIT, generation-based incentives, GBI, and tax incentives. Such incentives are crucial for driving investment and adoption in the solar sector. Infrastructure requirements. Policies should identify necessary land banks and transmission networks for deployment. This infrastructure is essential for integrating solar energy into existing grids. Processes and procedures. Clear guidelines are needed for project allocation, tariff determination, and grid synchronization. This includes establishing model power purchase agreements, PPAs, and safety protocols. Utility-scale projects. Eligible generators. Criteria for generators allowed to produce solar energy for sale, including licensed and private entities. This ensures a competitive market. Tariff determination. A transparent agency responsible for setting tariffs and related processes. This brings clarity to pricing structures. Project allocation. Details on project allocation processes, whether through competitive bidding or first-come, first-serve. This promotes efficiency in distribution. Model PPA. Guidance for buyers and developers, detailing agreement duration and tariff rates. This standardization streamlines negotiations. Grid synchronization. Procedures for integrating solar power into the electrical grid. This ensures effective utilization of solar energy. Grid safety. Ensuring the reliability and security of the electrical grid to prevent disruptions. This is crucial for maintaining service continuity. Distributed solar PV projects. Business models options include utility-owned, private developer-owned, and consumer-owned models. Each caters to different market needs. Capital subsidy. Guidelines on capital subsidies and application processes. This financial support encourages project development. Tariff guidelines. Define tariff rates for distributed solar PV projects. This clarity helps stakeholders understand financial implications. Project allocation. Transparent processes for project allocation, whether competitive or first-come, first-serve. This ensures equitable access to opportunities. Model PPA. Clear terms for energy sales and purchases. This facilitates smoother transactions and reduces disputes. Grid connectivity. Mechanisms for connecting distributed solar projects to the grid, such as net metering. This allows efficient energy transfer. Technical standards. Setting quality and safety standards for solar PV equipment. This ensures installations meet safety benchmarks. Grid synchronization. Procedures for synchronizing solar PV systems with the grid. This is critical for maintaining grid stability. Grid safety. Maintaining operational integrity for distributed solar PV projects. This is essential for preventing outages. Capacity building. Addressing the shortage of trained personnel is crucial. Policies should focus on identifying training needs and developing skill enhancement frameworks. Local manufacturing. Encouraging local production of solar components is essential for reducing costs. Policies should outline incentives and processes for promoting local manufacturing. Over the years, solar PV policies have evolved to match market dynamics. Declining costs of solar modules and batteries have shifted focus from subsidies to competitive bidding and auctions. Utility-scale projects now rely on reverse bidding, where developers quote the lowest tariffs. Rooftop solar installations are transitioning, with smaller capacities still receiving subsidies. Mini-grids and solar pumps continue to benefit from higher tariffs and capital support. Tailored interventions are essential to align policies with the solar sector's development stage, from nascent to mainstream. Let's explore real-world examples of solar PV policies and regulations. Uzbekistan's roadmap for solar energy deployment highlights targets, barriers, and policy frameworks for growth. Thailand's analysis of rooftop solar regulations identifies challenges and solutions for scaling up installations. Closer to home, India's Viability Gap Funding (VGF) scheme has supported solar projects by bridging the financial gap, enabling developers to achieve financial closure. These case studies demonstrate how tailored policies can address unique challenges and drive solar adoption globally. In conclusion, policies and regulations are the cornerstone of solar PV deployment. They address challenges, create incentives, and streamline processes to ensure sustainable growth. By aligning policies with market trends and tailoring interventions to the sector's development stage, we can unlock the full potential of solar energy. Together, these frameworks pave the way for a cleaner, greener future. To deepen your understanding of solar PV policies and regulations, here are some key resources. These documents cover topics like tariff computation, renewable energy integration, and distributed generation mechanisms. For instance, the Joint Electricity Regulatory Commission's tariff order provides insights into how solar tariffs are computed, while REN21's report explores policy incentives for renewable energy integration. Thanks for going through and reading. Don't forget to like, share, and subscribe for more solar insights from I-SED Academy. Please go to I-SED Academy platform for detailed learning about solar technologies.